So this is one problem where we use the expression for the magnetic force on a moving charge particle. Here this figure shows that the vectors v and b lie in the xz plane, and the angle between these vectors is 30 degree, and our target variables are the magnitude and the direction of the force. And okay, so this charge is positive, so the force is in the same direction as the vector product v cross b. From the right hand rule, this direction is along the negative y-axis, and the magnitude of the force is given by this basic formula sine phi. Just put the values and you can get the magnitude of the force. Force is 4.8 into 10 raised to power minus 4 Newton. You can also check your result by evaluating the force using vector language. How you can do that? V is convert the V into vector form, and then 3. To kick because it is in X and Z. Okay. Then B and just use this relation Q V cross B, and you can check your value of force and then compare either they are the same or not. So this is, just do it. After you watch this video, please do it, and if there is something, if you find any problem, discuss with me in the discussion session. Okay, now let's do one more a bit advanced problem. And in this problem, a uniform magnetic field is applied, and with magnitude of 1.2 millitesla, and it points vertically upward throughout the volume of the room in which you are sitting. Anyone is sitting, uh, because a student is sitting and he or she is seeing from here. So a view from above of a student sitting in a room in which a vertically upward magnetic field deflects a moving proton toward east here. This proton has is moving with a kinetic energy of 5.3 MeV horizontally to the north through a certain point in the room. What magnetic deflecting force acts on the proton as it passes through this point? The proton mass is this. So let's do it how we can do it. This is, we know the magnetic deflecting force depends on the speed of the proton or the speed of the particle on the V, or let's use this formula, K is equal to 1 by 2 mv square, and we are interested in speed. And after solving, the value you will get is around this. Now we are interested in finding the magnetic force. Then FB is Q, VB, and sine phi. After putting the values and simplification, you will get this answer. This is the force, and because this force is very small, but it acts on a particle of small mass, so even this force is very small, it will produce very large acceleration. And you can also find out the acceleration, which is here. This is 10 is for 12 meter per second square. You can also find this sample problem in your uh, book, and I just want you to do practice of this one, and if you find any problem in understanding this, specifically this problem, then also discuss with me tomorrow.